Have you ever wondered how the pH of a solution can affect the dissolution of an adsorbent? Well, let's dive right into it. Dissolution is a fascinating process where a solute, in this case an adsorbent, dissolves in a solvent to form a solution. Now, adsorbents are substances that have the ability to adsorb, or hold molecules of other substances onto their surface. Now, where does pH come into play? pH is a measure of the acidity or alkalinity of a solution. It's a scale that ranges from 0 to 14, with 7 being neutral. Acidic solutions have a pH less than 7, while alkaline solutions have a pH greater than 7. The pH of a solution can significantly influence the dissolution of an adsorbent. Depending on the nature of the adsorbent, a high or low pH can either promote or hinder its dissolution. For instance, certain adsorbents dissolve better in acidic conditions, while others prefer alkaline environments. So we see that the dissolution of an adsorbent is not just a simple process, but one that can be significantly influenced by the pH of the solution. Now that we understand what dissolution and pH are, let's delve deeper into how pH affects the dissolution of adsorbents. Picture pH as a sort of gatekeeper in this process. Depending on its level, it can either open the gates wide or keep them tightly closed. When the pH is high, it's like the gates are wide open. The adsorbent finds it easier to dissolve. This is because a high pH indicates a more alkaline environment, which promotes dissolution. Think of it as a warm welcome for the adsorbent to dissolve and mingle with the solution. On the other hand, a low pH is akin to the gates being shut tight. The environment is more acidic, making it harder for the adsorbent to dissolve. It's like a stern bouncer at a club, denying the adsorbent the chance to join the party in the solution. To visualize this, consider a sugar cube. When you drop it into a cup of hot tea, it dissolves quickly. But if the tea is cold, the sugar cube takes longer to dissolve. The temperature of the tea is like the pH of our solution, controlling the rate of dissolution. It's fascinating, isn't it? The way pH can sway the dissolution process of an adsorbent. As we wrap up, let's summarize what we've learned about the dissolution of adsorbent as a function of solution pH. We've delved into the captivating world of dissolution, unraveled its intricate chemistry, and explored the pivotal role that pH plays in this process. Just as a maestro conducts an orchestra, the pH of a solution orchestrates the dissolution of adsorbents. It's the unseen hand that guides and influences how adsorbents behave, dictating whether they dissolve readily or resist dissolution. The interplay of these factors isn't merely academic. It has practical implications for chemistry professionals, whether they're designing new materials, optimizing industrial processes, or tackling environmental challenges. So, as we've seen, understanding the dissolution of adsorbents isn't just about memorizing facts. It's about appreciating the complexity of the chemical world and the delicate balances that underpin it. Remember, the dissolution of adsorbents isn't just a chemical process, it's a dance influenced by the pH of the solution. Until next time, stay curious and keep exploring the fascinating world of chemistry.